Welcome to week 2 of the medicinal chemistry course. This lecture is entitled Organic Functional Groups, and we continue our exploration of learning how to identify organic compounds, and we'll go from there. Okay, by now you should know these following things. You should understand that carbon forms 4 bonds, and it forms 4 bonds all the time. And it can also form strong covalent bonds with other elements. Okay, and we can represent this in many ways. So here's a picture of a cyclic compound. Has a ring in it. In this case, it has oxygen in the ring. We can represent it. Here's another ring structure. You notice it has alternating double bonds. It has 2 chlorines in it, so this would be a dichloro compound. Okay. And we can represent it, as you've already seen, in a straight chain manner. You should be able to recognize this compound. Typically, it is often the case, as you've already experienced, that we will not show hydrogens. Everybody assumes that they know the hydrogens are there. If the carbon needs 4 bonds and it only has 2, then what's missing are 2 hydrogen atoms. Okay, and there's another pretty simple structure. And what you should also know by now is that anywhere where there's a junction or a zigzagging line, that represents a carbon compound. So there would be 2 extra carbons there where the lines cross. Okay, in terms of functional groups, these are parts of molecules that result in characteristic features, and these are going to play heavily into our study of medicinal chemistry. There's about 100 functional groups. We're going to focus on significantly less number of functional groups than the 100. We'll look at about 10 or so, maybe even not quite that many. As you get more experienced in organic chemistry, you'll certainly learn some of the other ones that we're not going to talk about here. We try to group these. There's an infinite number of possible organic compounds, as you will see as we get further into the course, and we try to group these as best we can. It's a challenging concept to get all these things characterized and grouped in some reasonable or meaningful way, but we'll give it our best shot. You should know by now that the simplest group is the hydrocarbons, and these are only carbons and hydrogens, and these really aren't considered to be a functional group per se. There'll be some folks who will say hydrocarbons aren't a functional group, but we can classify them as such, and we divide these, as you've already seen, into alkanes, alkenes, okay, alkynes, triple bond, and aromatics. But we also have the cyclic or cyclo compounds. Aromatics are mostly those compounds that have benzene rings in them. We'll talk about those later in this discussion. Okay, so here's a picture of hydrocarbons, and you should know this well by now. Alkanes all have single bonds. Okay, there's no double bonds in there. Alkenes all have at least 1 double bond. Remember, the key word there is that at least 1 double bond. It can have more than 1 double bond. It can have 2, 3, or more. Okay, and the ending there is -ene. Alkynes, as you've already seen, have at least 1 triple bond in them. And then the aromatics are compounds that typically have a benzene ring in them, and notice how we draw that. There's a couple different ways of notating aromatics. You see the full structural diagram on the right, and then you see the shorthand representations over on the left, and all 3 of those representations there represent the exact same molecule. Okay, so those are the benzene rings. Okay, here's a chart of all of the functional groups that you must know for this course. I'm sure you'll end up learning more than just what's on this page here, but these are the ones that you absolutely have to have memorized and be able to recognize in an instant as we go through the course. Okay, so alkanes, alkenes, and alkynes you've already seen. Over on the top right line, you see what looks like a benzene ring, but if I take 1 hydrogen off, then we have a functional group, and that's called a phenyl group, and sometimes we'll call it a benzyl group, but most of the time it's called a phenyl group. So if you are familiar with things like phenolphthalein, it has a phenyl group on it. You're going to see a lot of phenyl groups in medicinal chemistry. Okay, starting on the next row down in the middle, what's known as the alkyl halides. So you have an alkyl group, and notice there that alkyl is comes from the ALK, so it can be an alkane, an alkene, or an alkyne. And the YL there represents that it's a group. The halide can be a fluorine, a chlorine, a bromine, or an iodine. We're going to see an awful lot of those in organic chemistry. So if in this particular structure it has one carbon, so that would be a methyl group or a methane group, and if I put a chlorine in it, that would be chloromethane. Okay, that would be the name of that structure. An amine is a nitrogen containing compound, and nitrogens can have 3 bonds. So in this case, the nitrogen is connected to a carbon, and it has 2 hydrogen groups also attached to it, and that's an amine. An alcohol has an OH group attached to it, and some of you may be used to seeing OHs as being bases in organic chemistry. We don't look at them that way. We look at them as being representing an alcohol. Okay, an ether is a compound that has an oxygen bridge, and as you'll see momentarily, sometimes we call that an oxy compound. So in this case, you have 2 carbon groups attached with an oxygen bridge in the middle. Okay, on the bottom row are all your carbonyl compounds. We'll talk about that in a minute. You see where it has a C carbon double bonded oxygen, C double bonded oxygen. Okay, that C double bonded oxygen is called a carbonyl. And an aldehyde, there has to be a hydrogen connected to the carbonyl. A ketone can have a variety of things attached. A carboxylic acid must have an OH group attached to the carbonyl. An ester is going to have an oxygen bridge there, and an amide is going to have an amine group attached to the carbonyl. Okay, and we'll work on these as we go through this program. Okay, there are other names that describe patterns of atoms, as you've already sort of gotten a little taste of. Anytime we see an OH group, we call that a hydroxyl group. Okay, that refers to an alcohol. A carbonyl, as I just mentioned, is a C double bonded O, and a carboxyl group refers to the COOH. Now you have to recognize in there that that first CO there is a carbonyl, so it's a C double bonded oxygen, and then there's an OH group or a hydroxyl group attached to the carbon. Okay. And a question might be, which functional groups contain a hydroxyl group? Those are going to be the alcohols. A carbonyl group, there's a whole bunch of those. And a carboxyl group, those are going to be the carboxylic acids. Okay, so a hydroxyl, alcohols have them, carboxylic acids have them. Carbonyl, aldehydes, ketones, carboxylic acids, amides, and esters. Okay, a carboxyl group, carboxylic acids, and many properties such as boiling and melting point change because of these functional groups, and that's going to be a key consideration in medicinal chemistry. Okay, probably the easiest way to categorize these things is by showing you functional groups based on what they contain, and the biggest group by far is those containing oxygens. So you look over here, the name of the compound, the general formula, an example, and a name. So let's start with a simple group there, the alcohols, and what you see under a general formula is the R notation. R means some sort of group. So for example, if you remember methane, if we remove one hydrogen, that would now be a methyl group, and a methyl group is what we would know as an R group. So let's take a look at the example there. Okay, the general formula is ROH, so you recognize your OH there. And what is the R group in this case? The R group is a CH3, CH2, and if you sort of ignore the hydrogens, you've got 2 carbons there. You should recognize that as ethane. We remove 1 hydrogen, that now makes it an ethyl group. And so the name of this compound, you take the longest chain, which is ethane, you remove the E, and you add the OL ending, and that's representative of an alcohol. So this compound would be called ethanol. Okay, we could also call it, and you'll see this quite frequently, we could also call this compound ethyl alcohol. Okay, and ether is the next one down, and that's an ROR. So you have an oxygen bridge there. So if you look at the example, you've got a methyl group on the left, you've got a ethyl group on the right. So one name is going to be methyl ethyl ether. Okay, that's one name to call it. We can also find the longest chain there. The longest chain is an ethane. Okay, and we put the sort of bridge term oxy in the middle, and then to represent the other R group, which is a methyl group, we take the YL off and call it meth. So that's methoxyethane would be another name. Most people would probably call this methyl ethyl ether. Okay, aldehydes, notice it has an R group to one side of the carbonyl, and it has a hydrogen attached to the carbonyl carbon. Okay, so if we look at the example there, what's our longest chain? We've got 2 carbons, that's an ethane. We remove the E and we add the AL ending, and that's called ethanal. And many of these smaller aldehydes have what's known as a common name or a historical name, and this one is acetaldehyde, and you'll learn these as you get a little bit more experience. You might have heard of things like formaldehyde. Okay, so those are common names, but this particular compound, 2 carbons, ethane, take the E off and add an AL. Okay, ketones, okay, also have a carbonyl, and instead of an H, a hydrogen to the right of the carbonyl, you have 2 R groups. So if you look at the compound that's in the example, okay, what's the longest chain? You have 3 carbons, that's a propane. You take the E off and you add the -one ending, O-N-E. Okay, so this would be propanone. Okay, we could also call this a dimethyl ketone because there's a methyl group on each side of the carbonyl. You see the methyl group on the left, the methyl group on the right. So we could call this dimethyl ketone. And how do we know that there's that extra carbon there? Because the ketone is that carbonyl, that C double bonded oxygen. Okay, carboxylic acids. And again, you have the COOH structure there, the C double bonded OH. And there's a variety of ways to name these. If you take the longest chain, in this case you have 2 carbons, and that would be ethane. You take the E off and add the oic acid. And again, these things have some common names. This one is acetic acid, otherwise known as vinegar. Okay, an ester is our last oxygen containing functional group, and you've got a C double bond O R group. So in this case, okay, what you do is you find the longest chain that has the carbonyl in it. So if I look at starting with the carbon in the carbonyl, I got a CH3 that's going towards the left. So that's going to be an ethane. I take the E off and add O8. And then I look at the group that's attached to the oxygen bridge. This is an ethyl. So I have ethyl ethanoate, otherwise known as, this common name is ethyl acetate. And again, you'll get to see that. Okay. All right, so here are some examples of alcohols. I have methanol. Okay, so methane, take the E off, add OL. I have ethanol, take the E off and add an OL. Okay, I have 1 propanol. I count 3 carbons, 1, 2, 3. That's propane. I take the E off, I add an OL, and the reason it's a 1 propanol is because the alcohol is attached to carbon number 1. And that looks a little different than the next one, 2 propanol. Okay, if you notice that the alcohol is attached to carbon number 2, so that would be 2 propanol. The next compound down is a 4-methyl 2-pentanol. I count my longest chain, 1, 2, 3, 4, 5. And where's the alcohol attached? The alcohol is on carbon 2, and the methyl group is attached to carbon 4. Okay, and for these functional groups, you want to attach the functional group to the lowest carbon possible. So that's why we put the OL on carbon 2, and we put the methyl group on carbon 4. Okay, some ether examples. Okay, there we have the first one on the left-hand side there. We have a methyl group, we have an ethyl group, but in this case, so we can call that methyl ethyl ether. But in this case, I'm going to take the proper name is I'm going to take the longest chain, that's an ethane, and that's going to be the name of the compound. The oxy represents the oxygen bridge, and then as you've seen before, we have the meth group to the left of the oxygen bridge. Okay, if I look at the next one, I have my longest chain is an ethane. The other side of the chain is also an F, and I put an F-oxy in front of that, so ethoxyethane. Most people would call this diethyl ether. And the next one is I have a butane, that's my longest chain, so 1, 2, 3, 4 carbons. Okay, there's an oxygen bridge there, and what's attached to the oxygen bridge is an F group, or an ethane group, so that would be 2-ethoxy butane. You'll notice there ethyl sec butyl ether. Okay, the sec there means that the ether is on the second carbon. So there are some other ways we can name these, and we won't get too worried about these. Some of these specialized names, at least at the beginning. You'll get used to those as you get a little bit more experience. Okay, aldehyde names. No, the first one on the left has 1 carbon, and that's going to be methane. Take the E off, add Al. Most of the time we would call this formaldehyde. Okay, ethanol you've already seen, that's his acid aldehyde, and you'll get to know these common names as you get a little bit more experience. Okay, the third one over on the far right there, we have 3 carbons, 1, 2, 3, that's propane. I take an E off and add the Al, that's propanal, also known as propionaldehyde is our more common name. Okay. All right, ketone examples. Okay. Once again, I have 3 carbons. Okay, so that's propane. Take the E off, add the O and E ending. And we could also call this dimethyl ketone. And the more common name here is acetone or fingernail polish removal. Okay, butanone, 2-butanone is the next one over. And the reason that's a 2 is I count my longest chain, and I look to see where is the double bonded oxygen attached. It's attached to the second carbon. So that means the butane, the on the butane there is attached to the second carbon. And I could also call this methyl ethyl ketone. There's a methyl group to the left, there's a ethyl group to the right, and that's attached to a carbonyl ketone. So methyl ethyl ketone, also known as MEK. And this is a very big chemical compound. It's used to clean the sides of ships, and it causes an awful lot of pollution in the oceans and places where ships go. Okay, this next structure over is our first structure that you've seen with a halide in it. Okay, so what you have to do here is count your longest chain. I got 1, 2, 3, 4, 5 carbons. That's a pentane. And because I have a carbonyl there, that's going to be an one, and the one is attached to the second carbon, so 2-pentanone. And using 2 as my starting counting place, I count over 3, 4. Where's the chloro attached? That's on the 4th carbon, so that's going to be 4-chloro, 2-pentanone. Okay, so those are examples of ketones. Okay, carboxylic acids. First one there, I have 1 carbon, methane. Take the E off, add an oic acid. That's methanoic acid, otherwise known as formic acid. And many of you, if you've ever gotten bitten by an ant, it stings a lot, and that's because what you're getting bitten with is a little bit of injection of formic acid. That's what ants have in their mouths, and it stings because it's an acid. Okay, ethanoic acid, 2 carbons, and I take the E off of ethane and add an oic acid. This is again also known as acetic acid. Okay, propanoic acid you've seen before. And look at the one on the bottom there. Again, count your longest chain. 1, 2, 3, 4, 5, 6 carbons. Okay, so that would be hexane. Take the E off, add oic acid. And we always start counting, when we count these things, the carbonyl carbon is carbon number 1. So the methyl group is on carbon number 2. And if I keep counting over to the left, 3, 4, 5, the chloro group is on carbon number 5. So that's going to be 5-chloro, 2-methyl hexanoic acid. What a mouthful. Okay, amines are basically the same idea. Okay, if you look at the first one, top left there, I have 2 carbons. That's my longest chain. That's going to be an ethane. I take the E off and add the name amine, and so that's ethane amine. Most people would probably call this ethylamine. Okay. The next one over, longest chain is 4, 1, 2, 3, 4 carbons, and I have an amine attached to carbon number 2, so that's 2-butane amine. Okay, and again, some people would call this sec-butylamine. Okay, next one over, top right, count my longest chain, 1, 2, 3, 4 carbons, and that's going to be a butane. Take the E off, add amine, and in this case the amine is attached to carbon number 1, and if I count over from carbon number 1, 2, 3, the methyl group is on carbon number 3, and that'd be 3-methyl-1-butane amine, also known as isopenylamine. You notice there the next one, bottom row to the left, I have my longest chain is an ethane, so that's ethane amine, and sometimes we'll use the N notation to represent that there is a methyl group attached to on the other side of the amine group. Most people would call this ethylmethylamine. See if you can figure that out. Okay, and the last one there is an NN-dimethyl-2-butane amine. Okay, so see if you can work your way through that structure there. Okay, you also have some nitro and nitrile compounds. You're going to see these a fair amount in medicinal chemistry. The nitro group is an NO2 group, and in this case, if you look at top left, we have a butane, 1, 2, 3, 4 carbons, and on carbon number 2, there's a nitro group attached, so this would be 2-nitro-butane. Okay, the next structure over, we have a benzene ring, and we have a nitro group attached to it, so this would be nitrobenzene. And a nitrile is going to be a C triple bond N compound. So in this case, we have 2 carbons, 1, 2, that's ethane, okay, and you just simply add nitrile to it. So you have ethane nitrile, and again, the common name is acetonitrile, and you'll get to know these compounds as we go